Hey there, CS360 students. So let's talk about part 2 of chapter 1 where we're getting introduced to Android development. So inside Android Studio, it offers to you the capability of logging data messages to a log. So for those of you that are newer to production level code, it's pretty typical where we're going to log statements, kind of giving us some breadcrumbs along the way to know where our code is, what it's been doing, and so forth. So the log tool inside Android Studio has a log class. So you can see that we can just import log from the android.util. And it has different levels of logging that we can utilize. So D is debug, E is for an error message, I would be information. So these are kind of different levels of information that we might be concerned with. Uh, Inside, as an example, they've got a tag here that they declared as a string saying that this is the main activity. And so what I can do is I can do log.d. So this would be a debug statement. This is going to then tell me which tag I have, and then some kind of message here. So you can see that in the log cat, main activity was the tag, and then it called this string right here. So this is very useful to pull up in the logcat and see exactly where you are. A common practice is on an onCreate, we state that it was started, and then at the end that it finished. So a good way to create breadcrumbs if you ever need to debug without running the application. It will also print out stack traces to you. So again, I'm sure you've seen a stack trace at some point in your writing code career. So you would then go look at the file, and then hopefully it's one of your files, and then you can go look at the line number and try to figure out exactly where things are going wrong. You can also debug your code inside Android Studio. You can place breakpoints and then run with debugging. And this works for on a virtual device or if you're using your own device. And when the code gets to this point, it's going to break. You can hover over things and see the value that it contains. And also IntelliJ is nice enough to display it on the side here as well. You can then step over your code. So this will be at the very bottom of the screen. You can step over one line of code at a time. If you come to a method, it would step into the method. And so forth. Okay, next section we're going to look at is the app manifest file. So every app has an Android manifest file. It's an XML file specifying the important information about it. So what important information are they going to have in here? So it's going to have the package attribute. So this is going to be the identifier inside the Android running operating system. It's going to have the application, where it's going to tell you what the icon for the launcher is, a app name, the theme that it's using, and then what the main activity is. We can also have features that the hardware or software device capable may want to use. So it may be wanting to use Bluetooth or camera or backup. So those are going to get specified in the manifest file as well. And then we might also have to ask for permissions. So we might ask for permission to use the camera or call on the phone or read contacts. So when your app starts up, you're going to get a window very similar to this that the user has to either accept or deny. Okay, next thing we're going to talk about is that Android development itself supports what we say is called Model View Controller. MVC is a popular architecture approach where we have a user interface and then a controller and model that are being interacted with. You can think of the model as a class that contains the business logic. The view is the user interface that's either going to display output or be asked to give input from. And then the controller is the go-between those two entities. So if I scroll down here, they have a really good example. So let's suppose that we've got a pizza calculator class. It has a hunger level, a party size, and typical constructor getters and setters. But what we're really interested in here is it has a get total pizzas. So this is a business logic here, whereas this pizza calculator is living, I can ask it for, hey, how many total pizzas should I get based on the hunger level and the party size? If we then scroll down to the controller here, so our view is passed in, and we can get input from the user interface, and then we can also display output. So right here, here's setting the text, we can display output. So very typical in our controller, we're going to get the input, we're then going to go to our model and ask it to perform some business logic, and then we get the output right here. Okay, last couple sections are going to be talking about testing in Android and in Android Studio. So if you've never created a unit test just tests a small method or a class or a component. Most typically, it's going to be testing a method. So we might have some kind of method right here, and then we create a unit test that's going to test whether or not this method works. We typically use this using JUnit, the library, so that's a very popular testing framework. And then it supports annotations of at test, before, after, handling things before and after the case. And then methods that we are interested in to test are asserting if something is true or false, or if they're equals, if they're a match, and so forth. So Android Studio does support creating unit tests. So you could go to the test directory and create tests for individual units, individual methods. Or we might have what's called an instrumented test, and these have dependencies on Android. So you might be doing something that's based completely on an Android dependency. For instance, the colors of something, where it's going to read the colors resource. So keep in mind, instrumented is always going to be something that is a dependent test. And then the last thing to look at is just some testing fundamentals. If I scroll down here, a testing pyramid often looks like this. Testing that the UI performs properly is going to be the least amount of tests. That's because these take the most amount of time and often are not able to be easily automated. There are some tools out there that will let you automate clicking a button and checking if things were returned and so forth, but that's harder to implement. Integration tests are tests that verify that multiple app components are interacting correctly. And then lastly is a unit test, so a single unit, a single method getting tested. So you can see it, typically we have most of these. These run very fast because we're just testing one thing. So keep in mind that we can test a mobile system, and ultimately, what would be ideal is if you had some test-driven development where you wrote a test and then implemented the code, found out whether or not it passes, and then you refactor until it does actually work. Okay, that's it for part 2.